Today we will talk about a transformer ventilation system as per local regulation. Clear?
Okay. Mhm.
This is one of the high-risk tower project where you can see the transformer room, where you can see the generator room, then you can see the LV room. Okay. Normally, you know that the incoming power from authority, which comes to the transformer room from HV to transformer, then from the transformer it will go to the LV panel, right? That is the LV room. Here you have a multiple panels where the power will be coming from the HV room to transformer and to the LV room just to step down the voltage.
Oh,
Clear?
okay. So
In
HV room goes to transformer, and then from there it goes to the LV rooms, right?
Yeah, normally HV room you can talk about like 11 kV, then 33 kV, something like that. Okay, so
Mm-hmm.
that is like 11 kV is nothing but 11,000 kilo voltage. Okay, kilovolt.
Yeah.
So
Kilowatt.
that
Yes, yes.
voltage you are going to step down to make it like a 400 volt, right? That is what
400.
required for our building. Okay, so
Mm-hmm.
the transformer is used to step down the voltage from 1100 kV to 1100 voltage to 400 voltage.
To 400 voltage. Yes.
Yeah, yeah. Basically 11,000 volt to
Yes, yes. 11,000
400
volt.
volt.
Yes.
Okay, to 400 volt. Okay. In case if there is
Mm-hmm.
any failure in the power side, like authority side, what will happen? The transformer will be like you will not get the power. Okay, but in that case, your generator will get kicked right through the ATS.
Yeah. Mm.
Okay, so what will happen when the power comes from authority? It will go to the transformer, then it will go to the LV. Or in case of power failure, the power comes from generator to the transformer, then from the transformer to the LV.
Oh, okay. Okay. So this HV
Okay,
itself is basically from the government, from the DIVA, right? If I'm not wrong, in our example,
yeah, in local from local power supply provider.
local power. Okay. Okay. Yeah. Yeah.
Okay, see the generator. You have a two type of generator. You have a high voltage generator and you have a low voltage generator. So low voltage generator, it will directly come to the LV panel.
Okay.
Okay, if you have a high voltage generator, then it will go through the transformer, then again it will come to the LV panel. So this is the procedure,
Okay. Okay.
right?
Mm-hmm. Okay.
Okay,
Okay.
so whenever the power carries through the transformer is also one of the equipment. Okay, so if you go to the regulations, you can see there are transformer room where you can see the transformer, right?
Mm-hmm.
Okay, so whenever the power transmission is happening, like from HP to LV, the power goes through the transformer, so the transformer produces a lot of heat, right?
Yeah.
Okay, so it depends upon the efficiency. Say, for example, the transformer has to work for 100 percentage, but normally no equipment will produce 100 percentage. Okay, there will be some
Yes.
percentage of efficiency, right? So you can talk about
Yes.
like a 95% or 96% or 97%
Mhm.
or 98 percentage, depends upon the efficiency, right?
Okay.
Okay,
Yeah.
so the 2 percentage will be loss, heat loss. So in case if you
Yeah.
say 98 percentage efficiency, that means the 2 percentage will be loss, right?
Yes. Yes.
So that 2 percentage will be the heat dissipation, okay, inside the room.
Yes.
Okay, so that heat will be generated inside the room, then excess heat to be taken out from the transformer room. So that is what we are doing, transformer ventilation. Clear?
Understood. 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 Yeah.
The excess heat to
So
be taken out. If you don't take the excess heat, what will happen? The transformer will be overloaded or will be overheated. Then the transformer, there is a chance of fire, or maybe the transformer will not properly efficiently it will work. Maybe the efficiency of the transformer will go down. Clear, right?
mm, yes. Yes.
Okay, so this is what we are going to calculate the transformer ventilation fan to take out whatever the heat, excess heat, whatever generated in the transformer room that will be taken out through the transformer ventilation fan.
Okay.
Okay, so now what we are going to do, if you go to the my calculation sheet, you can see the transformer room ventilation. Okay, basically you are going to calculate what is the heat dissipation in the transformer, right?
Yes.
To calculate the heat dissipation in the transformer, you're going to find out what is the transformer kVA rating, then multiply by number of transformer,
Mm-hmm.
then the power factor to convert from kVA to kilovolt, kilowatt.
Okay. From kilovolt to kilowatt. Yeah. Okay.
Okay, kVA to kilowatt. Okay, so you know the value like kVA is equal to power factor multiplied by
Uh,
sorry, it is other way. Kilowatt is equal to kVA multiplied by power factor.
okay.
So then you will get kilowatt.
Mm.
Okay, now the transformer
Mm-hmm.
efficiency. So to calculate the transformer efficiency, you are going to put what is the percentage, right? In the percentage is nothing but like a 98 percentage or 99 percentage or 97 percentage, whatever the percentage of efficiency in fraction,
Mhm.
right?
Mm.
So this is like
Mhm.
eddy loss. Okay, you can call it as eddy loss. So 1 minus transformer eddy loss.
Mhm.
Okay, so now you are
Understood.
going to calculate the heat dissipation. Just multiply by the transformer kVA rating, which is assume that it is like 1500 kVA, right?
Mhm.
Multiply by number of transformer, which is one number. Okay,
Mhm.
okay. Then the C19. C19 is nothing but the power factor, which is 0.8.
Yeah.
Okay, then multiply by in 1 minus transformer eddy losses, like a transformer efficiency, which is in percentage.
Okay.
Okay, percentage is like 98.4, but if you make it as a fraction, it will be like 0.984.
0.98. Yeah.
Okay,
Mhm.
so when you calculate, you can able to calculate the heat dissipation of one transformer.
One transformer. Mm.
Clear?
Yeah. Okay. So
Okay,
okay. So each transformer will have its own independent kilovolt, right? Okay. Okay.
yeah, kilowatt. Okay, so if you have a say, for example, in your project, you have a 500 kVA, or you have a 1000 kVA, or you have a 1250
Mm.
kVA, or 1500 kVA, you can able to calculate the heat dissipation for that particular transformer.
Okay.
Okay, I assume that this 1500 kVA is 0 and 1250 kVA is one number. So you can see the heat dissipation value, right?
Mm.
Okay. Now with the picture comes like you know that sensible heat formula, right? Because the transformer is a
Yes.
purely a sensible heat equipment, right?
Yes. Yes. Yes.
Okay. So
Yes.
you are going to calculate the sensible heat, which is equal to the same equation, 1.08 multiplied by delta T multiplied by CFM.
Yes.
Okay, from here we are going to calculate the CFM because we are going to calculate the fan capacity, right?
Yes.
Okay, to calculate the CFM, you can able to calculate CFM is equal to heat dissipation divided by delta T, then 1.08.
Okay. Understood.
Okay,
Yes. Yes.
okay. Now
Okay.
CFM,
Yeah.
you are going to find out the delta T will be the temperature difference between from outdoor to indoor, basically. Like you mean, say for example, if you go to ASHRAE, okay,
Mm-hmm.
okay, in the ASHRAE, you can see chapter 2019 ASHRAE handbook. You can see the electrical equipment, which is enclosed transformer equipment areas. Okay, so here you can find out what is the maximum and minimum temperature.
Okay. So
Clear,
this is
right?
ASHRAE Handbook 2019, right?
Yeah, 2019.
Mm-hmm.
Okay, so you can see that the maximum temperature will be like the design outdoor. Okay,
Uh-huh.
okay, plus 6 degrees Celsius. That is the maximum temperature.
Okay.
Okay, you
So that
understand,
means
right?
46 plus 6, right?
Yeah, 46 plus 6. Okay. But if you
Mm.
go to local regulations, what they are saying, you can see that the maximum ambient temperature at air inlet in Dubai is 48 degrees Celsius.
Mm.
Okay. And if you talk about the temperature difference, what as per local regulations, they are taking 7 degrees Celsius or 7 Kelvin difference.
Mm.
Okay. But if you go to ASHRAE handbook, they are saying that plus 6 degree, but we have to follow the local regulation, which is they are mentioning that 7 degree Celsius or 7K, the difference, temperature difference.
Mm.
So you
Mm.
can say that 48 plus 7 degree, right?
1 second. So 48 minus 7 degree, right? Or
No, 48 plus 7 degree. You can see
Mm.
that ASHRAE handbook design outdoor plus
Yeah.
6 degrees Celsius.
Yes.
Okay, the minimum temperature
Yeah.
will be as per the ASHRAE guideline. Like if you go to
Yes. Yes.
ASHRAE,
Understood. Yeah.
ASHRAE,
Yeah.
ASHRAE, you can take like a 0.4 percentage, 99.6 to take the
Yes.
maximum temperature. Okay, that is a design outdoor plus 6 degrees
Mm.
Celsius.
Mm. Yes. So that would still be 40 if it was for I think as per the this thing I think it's 44, right? Or in 44 or 46 in the ASHRAE
No,
table. I'm not sure.
yeah, if you go to ASHRAE table, assume that you are like as per the local regulations. Okay, if you go as per local regulation, it is 48 degrees
8.
Celsius. Okay, but
Yes.
if you
So
go to that
48
standard,
plus
but if you go to as per ASHRAE, you can go to the fundamental. ASHRAE
Yeah.
Meteo
Weather
software,
data and then
you can able to take the weather data. Okay, but we have to
yes.
follow the local regulation, which is 48 degrees Celsius, right?
Oh, yeah. So 48 plus 6.
Yeah, plus 6, or you can say that the difference, you can see the difference, they have given 7 degrees Celsius, right? 7.
Hmm. 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 Hmm.
Okay, so that is the what, that is the same thing they have taken here. The temperature difference,
Yeah.
7 degrees Celsius or 7 degree Kelvin.
So basically, your delta T should ideally be 7 degrees.
Yeah, 7 degrees. Okay, so that means you can talk about that the ambient temperature design outdoor is 48 degrees Celsius plus the which is outdoor, the transformer can work up to plus 7 degrees Celsius maximum.
Hmm. 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 Hmm.
Okay,
Hmm.
okay, clear, right?
So 48 plus 7 means 55 degrees Celsius.
55
That's
degrees
the
Celsius. Yeah,
yeah.
55 degrees Celsius. Okay, then
Yeah.
go to the
Yeah.
table. You can, you know that to find out the value, you know the equation, which is sensible heat is nothing but CFM multiplied by delta T multiplied by 1.08. Okay, so we know we are going to calculate the CFM. Okay, we know the heat dissipation value in BTU per hour. Okay, whatever we calculated,
Yeah.
it is in kilowatt, and you can able to convert into BTU per hour just by using the formula
Yeah.
conversion, right?
Yeah. Yeah. Yeah.
Okay,
Hmm.
then we calculated delta T, right? For example, if you go to this value, okay, 48 degrees Celsius, and you are converting from Celsius to Fahrenheit, because our equation
Yeah.
will be BTU per hour is equal to CFM and your delta T in Fahrenheit, right?
Yes.
Okay, so
Yes.
you are
Yes.
converting from degree Celsius to Fahrenheit. So the 48
Hmm.
degrees Celsius will be 118 degree Fahrenheit, and the 55 degree Celsius will be 131 degree Fahrenheit. So the temperature difference between maximum and minimum will be 13 degree Fahrenheit.
Hmm. 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 Okay. But we said we need 7 degrees only though, right? That is the
Yeah,
acceptable value.
yeah, 7 degree is the delta K in Kelvin.
Yes.
Okay,
Okay.
okay,
Hmm.
but we are using the equation in imperial, right? Like
In
say for
imperial. Yes.
example, BTU per hour
Understood.
CFM multiplied
Yeah.
by delta T. Okay, if you
Yes.
are
Yes.
using
No.
it
No. No.
everything
I
in,
understood. I understood.
yeah, if you are using everything in kilowatt, then you can take it degree Celsius. But if you are using it in imperial, like BTU per hour CFM, then you can able to convert from Celsius to Fahrenheit.
Yeah. Yeah. So basically, when we say 7K, it is actually 7 Kelvin though, right?
Yeah, 7
So
Kelvin.
yeah. So but say for example, when we say Q is equal to mCp delta T with in the SI units, we would say Q is equal to 1.2 into, that's how we do this thing, right?
Yeah,
1.2
yeah,
into flow rate into delta T. So we
yeah,
would still retain the 7 though, right? That is the idea, right?
yeah, 7. Yes, yes.
Yes. Okay. Got it.
Oh,
Got it.
okay. So now you can you know that how to calculate the CFM is equal to BTU per hour divided by delta T, then 1.08, right?
Yeah.
So from here you can able to get the fan capacity, which is in CFM. Then you can able to convert into liter per second, or you can able to
Yes.
convert into meter cube per hour.
Per second, depending your based on this.
Yeah.
Mhm.
So this is
But
the, yeah,
yeah. So, please tell me. Please continue. Please continue.
yeah. So this is the fan capacity, whatever we require to calculate, whatever the heat to be taken out from the transformer room. Okay. So this is the airflow rate which is required to whatever the heat which is coming from the transformer should be taken out. Okay.
Understood.
Yeah. In
But
other
let
way,
me ask
yeah,
you one question, please. So this
yeah,
heat dissipation formula that we've used, that's kilowatt equals transformer kVA rating. That is, say if we have based on the number. So we will only do it per transformer. That's what we're trying to find, right? For each transformer, how it is. Like for example, say if I have 1250 kVA. For 1250 kVA transformer, I've got like say 3 numbers. So I would still be doing like 1250 kVA into number of transformers, that's 3, into then your power factor, which is uh, zero
point
0.8.
0.8.
Yeah, but this power factor basically comes from your manufacturer or
No, it comes from local authority. If you go to the
local.
local authority, like local power supply provider, okay, they will tell you that what is the power factor they have to, everyone has to consider.
Oh, okay.
Okay, so normally our local power supply, the power provider, they will tell you that what is the power factor. So normally in our local condition, it is like a 0.8. Like
Okay, okay.
Dubai, like countries, it is like 0.8.
0.8. Understood. Understood.
Okay,
So
then
then 1 minus the transformer
efficiency.
ID loss basically is the efficiency, but that I think will come from your manufacturer, right?
Yes, manufacturer, yes.
Okay. Yeah.
Okay,
Okay.
so by
Understood.
this way, you can able to calculate your flow rate, right? Air flow rate.
Yes.
Okay, there is another method, simple method is there. If you go to local guideline, okay, you can able to see the chart, right? Chart.
Yes.
Okay, example, assume that this is the heat dissipation they have calculated for one of the transformer, which is 1000 kVA. Okay, they assume that four number of transformers, right?
Mm-hmm.
Okay, so the same formula, how we calculate the same formula, okay, they calculate the heat dissipation. Okay, the heat dissipation they have calculated for one transformer 1000 kVA. You can able to enter the value as well here. Assume that you have a four transformer, and if you put zero this one, okay, you are getting approximately 51.2, right?
Yeah.
Okay, they have calculated 51.6, which is very closer value. Only the fraction is difference.
Okay.
Okay, the same equation. How they calculate the transformer kVA from kVA to the heat dissipation. Okay, assume that I can able to calculate for one transformer. So what is the value? It is approximate 12.8, and if you go to the guideline, they have given 12.9. So it is a fraction.
Mm.
Okay, so this is the value. They calculate the heat dissipation the same by using the same equation. Then they multiply by four number. They got the total losses in the transformer, right?
Yes.
So
Yes.
here you can see the table. There is a losses. Okay.
Mm-hmm.
Then you can see the table for the delta T. You can see the value here, right? Delta T.
Yeah.
Okay. And you can see the airflow rate. Directly you can take the airflow rate.
Oh, okay.
Okay. Now what is the delta T? You can see the temperature difference 7
Seven.
degree Kelvin. So you go to here 7 degree Kelvin, and for this temperature you can able to calculate the airflow rate directly. See approximate 23,000 meter cube per hour, right?
Mm-hmm.
Okay. So either you can use this particular calculation sheet to calculate the airflow rate in CFM
Or
or meter cube
mm,
per hour or in liter per second, or go to the chart. Then you, from the heat losses, whatever you calculated based on the delta T, you can able to calculate the airflow rate here directly without using the formula.
mm-hmm. But you would say, for example, say you have, but this is only for Diva though, right? For example, if you use a project in, say, some other country in the Middle East, for that matter, you
Yeah.
would still use the local regulations there, number one. But I would say
Okay.
still the formulas would still be the same though,
Yeah,
right? If you're
still
using
it will be the same. Still it will be the same. Only your ambient
same,
temperature will change. Okay, and
same.
for the transformer plus 7 degrees Celsius. That is as per ASHRAE.
Yeah, transformer
Okay,
room max temperature, right? Okay.
ambient temperature and the maximum transformer room maximum temperature.
Mm-mm.
Okay,
But
so
yeah,
that
this
will
is
be
one thing. I'm sorry. I'm just getting a small confusion here. So this ambient temp. So if you go back to the ASHRAE guide, it says ambient temperature plus 6 degrees. Correct?
plus 7. Actually, you can see the
Uh,
delta T directly. They have given 7 degrees Celsius.
Delta T is 7 degrees. So basically, what you would be is, so just for, if we are doing it correctly, design outdoor plus 6 degrees. That means say whatever temperature we have in the ASHRAE chart plus 6 degrees, and then the other one, that is the so basically that temperature is the sorry, that is the temperature that's inside the plant room, right? Or the transformer room, basically.
Yeah, transformer room. Yeah, transformer room will be same as
Design.
like ambient temperature.
No. Can you go back to that Excel sheet, please?
Yeah,
So what I was saying was there's the ambient temperature which you've calculated, which is 118. Then
yeah.
transformer room temperature, you have done it based on okay, you have used the local code, but if you're using ASHRAE, it would be 118 plus 7, correct? 118 plus 6, sorry.
118 plus 6. Yeah, you can say like that.
Yeah.
6 or like
Okay.
7. See, they have given the value here. Design outdoor plus 7, or they have given that minimum we have to take like 7 degrees Celsius.
Okay. No. Yeah, that is the minimum 7. So I just took the maximum value here. That's why I was just using that. The design, if you see for diesel, that's diesel generator. But for transformer, it's still the same. Like,
Yeah,
one
transformer will
second.
be the same. Yes.
Okay. So
This is
design
for
outdoor plus 6.
this is
Yeah,
for
got it.
transformer. Yeah.
Understood. Understood. Yes. 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 So basically, so yeah, but that 7 is basically just to give, that is the delta T that we have to ensure.
Yeah,
So if
delta
we
T.
minus both the temperatures, that's the dry bulb. So not the dry bulb, the outdoor temperature minus the added temperature to get the added temperature in the room, that is design temperature plus 6, should basically be minimum 7. Right.
Yeah, minimum 7. Yeah.
Understood. Got it.
Okay, right?
Yeah. It's clear. Yes.
Okay.
Yes.
So
Yes.
this is the way you can able to calculate by using the formula or by local code, local regulations. You can able to
Mhm.
use the same by using the chart.
So basically, I mean, I'm sure you would be doing this from stage to stage, but in your concept design or in schematic design, you you would only do more like a high level one, like you've seen in the authority, or you still use the Excel sheet as your
No,
reference? How do
same Excel
you?
sheet only. Excel sheet only. See,
Excel
only the transformer value may change from concept to detailed design. Maybe during
detail design.
concept they will say 1,000, and when we go to detailed design, maybe they will tell you 1250 kVA. Only that value will
Mhm.
change, but the concept will not change. How to calculate the airflow rate, that will not change.
Yes, understood. Think, yeah,
Clear?
think I've got it. Yes, yes.
Okay.